Very pleasant good morning. In this video, I am going to discuss about functional dependency in the database management system. So, before that, we should know what is the relation database, what is the aim of the relation database design. So, the main aim of the relation database design is to generate set of relation schema that allow us to store the information without unnecessary redundancy. This can be accomplished by designing the schema that are appropriate to the normal form. So, normalization is a method of organizing data into the database which helps to avoid the data redundancy, insertion, updation, deletion, anomaly. It's a process of analyzing the relation schema based on the different functional dependencies and the primary keys. So what do you mean by the functional dependency? Actually, it is a constraint that determines the relationship of one attribute to another attribute in the database management system. So functional dependency helps to maintain the quality of data in the database. How the functional dependency is denoted, that is X implies Y. So X implies Y. In such a scenario, X is a determinate attribute, since it should be a primary key. That is to determine the values of Y. Y is a dependent attribute. So the functional dependency is denoted X determinant Y. Next, we can determine the features of good relational schema. Relational schema are designs. Suppose we combine two different schema. One of the schema is called as a department and another one is a schema named instructor. So department is consist of department name, building and budget. Instructor schema consists of ID, name and department salary. So when we combine these two schema, definitely it produces it contains the large schema. So in department, it contains ID of the instructor and followed by the name of the instructor and department salary and followed by department name, building and budget. This represents the results of natural joins on the relations corresponding to the instructor and department. Natural join is a type of equal join that is constructed in such a way the columns with the same name of associated table will appear only once. So here we face some issues, that are repetitions of information. When we repeat the department information, that is building and budget, that is repeated for more than one instructor in the department. So we need to use null value of when we add a new department with no instructor. In that scenario, in this large scheme, we can add a department name, building and budget and null value for ID, name and salary. So we cannot represent directly that information concerning to the department name, building and budget unless the department has at least one instructor at university. So that we can relation database design begins department. It will be containing the different kinds of different tuples with ID, name of the instructor and ID of the instructor and salary and followed by the department attributes. So when you consider alternative way to design that relation schema into smaller schema, in that scenario, repetitions of results, informations resulting from having to list the building and budget once for each instructor that should be associated with the department. A real-world database has large number of schema and even for large number of attributes. So the number of tuples can be in a millions or higher. So the discovering the repetition would be a costlier one. Then we can try to find how to solve that kind of issues. You combine the schema without repetitions. So we can consider all combined schema, the result is not in repetitions of information. Consider this kind of two schema. One is called as a class, another one is called as a section. So section class schema containing section ID, building and room number And section schema containing course ID, section ID, and semester and year. When we combining these two schema into section, it will be contain course ID, section ID, semester and year, building and room number. There is no repetitions in this case. So we can consider the avoidance of repetitions of information. How to determine by using the decomposition of the schema. So one way to avoid repetitions of information, the problems in the department schema decomposed into two, that is instructor and the department. So not all decompositions are good. Suppose we can decompose employee ID and that is employee 1 and employee 2. So the employee schema that is divided into or decomposed into two. One is employee 1 and employee 2. So the employee 1 consists of only ID and name, and employee 2 consists of name and the street and city salary of the respective employee. So problem will be arise when we decompose, when we have two employees with the same name. In that scenario, we face the problem of loss of information. We cannot reconstruct the original employee relation, so that the relation is called as a lossy decomposition. When the schema decomposed into two without any loss of information, then we can properly decompose the schema. Suppose if there is a loss of information, then it is considered as then it is suggested as a lossy decomposition. So take as an example, the ID of employee table consists of the ID, name, street and city salary. It will decompose into employee 1 and 2. When we combine these two, employee 1 and 2, the schema into a single one by using the natural join, it will be loss of information when the same when the same employee, more than one employee have the same name. So that is that will be considered as a loss of decomposition. Now we can consider as a lossless decomposition. So lossless decomposition, that R is a relation schema that is partitioned into or decomposed into R1 and R2, that form a decomposition of that form a decomposition of R, that is R which is equal to R1 union R2. So we can say that decomposition is lossless decomposition. If the decomposition, there is no loss of information by replacing R with the two relations of R1 union R2. So that is mutual join of R1 with R2 which is equal to R. So conversely, we can decompose it as lossy if R contain R mutual join R2, that is also the result should be an R. That is for an example. If a dic R is a consist of an attribute A, B, C, then it is decomposed into R1 and R2. So R1 consists of an attribute AB and R2 consists of an attribute BC. Now, so this is original relation R. So this is for R1, third one is R2. When we combine these R1 and R2 by using the natural join, it will be produced the same result of R. Then that kind of decomposition is called as a lossless decomposition. Thank you.